Alright, we're going to look at section 1.1 in the book, and this is going to be in two parts. We're going to talk about up to absolute values, and then we're going to talk about some more complex absolute value problems. So we're talking about linear equations and some absolute value equations in this section. And linear equations are equations that only have the exponent on any of the terms is no higher than 1. So this one would not be a linear equation. This one's not a linear equation because there's no equal sign. So when you graph a linear equation, the graph that you will see will be a straight line, or it will be, as in the absolute value case, two lines that converge. So when we're talking about a contradiction is an equation that has no solution. So, for example, it might end up being 10 equals 0, or it might end up being x equals negative x, or something like that. So, a contradiction, something that has no solution, also means that the lines are parallel. So, anytime you have parallel lines or lines that don't touch, that's when there's going to be no solution. A conditional equation is an equation that has one solution. That's what we've been used to dealing with in the past. Is one solution. And an identity is an equation that has infinite solutions. So infinite solutions would come out to be something like 10 equals 10, 0 equals 0, or something like that. So in the case of an identity, what you end up with is two lines that are superimposed on top of each other. So you have a line on the graph, and then there's basically another line on top of it that has a different format or a different equation. So on these, we want to identify whether they're identities, contradictions, or conditional problems. So a contradiction for the first one, because there's no case where x plus 1 can equal x. So if I were to solve this for x, then I would probably subtract this x from both sides, and I would end up with 1 equals 0. So you end up with a situation that doesn't exist or it's not true. So that's how you know it's a contradiction. The next one, x plus 1 equals x plus 1, is an identity because you have the exact same thing on both sides. This next one is a little deceptive. So you have 2x plus 1/3 on one side, and you have 6x plus 1 divided by 3 on the other side. But if I divide both of these terms by 3, I end up with 2x plus 1/3. So I end up with the same thing on both sides. So it's an identity. This next one, if I solve. So what I did here is I added 5 to the side, and I got 2. And then I subtracted 6/9 from this side. Well, 6/9 is the same thing as 2/3. So I end up with 0 equals 2, so that's a contradiction. Okay, so here are a couple of examples. I want to solve this one. I want to solve for x in all these cases. So these are some equations that you should be familiar with how to solve. So this first one, because of the two binomials, we have to FOIL it out. Remember, FOIL means basically we distribute. You might not have called it FOIL, but we have to distribute into this. So we end up with 2x squared plus 3x minus 4x minus 6. And then on the other side, we're going to just distribute the 2x. So we get 2x squared minus 2x. The 2x squareds are going to cancel out because I'm going to move them together, and one's going to cancel the other one out. The 3x minus 4x becomes negative 1x. And then I just start combining like terms, and I get x equals 6. So there's one solution to the problem. I'm going to go down. This next problem, I work from the inside out, so I'm going to distribute the 3 inside. So I end up with 4 on the outside, 3x minus 15, that plus 7 continues down. Then I need to distribute the 4, so I get 12x minus 60 plus 28, 12x minus 32, and then I start combining like terms, and when I do that, I end up with this statement right here, 12x minus 32 equals 12x minus 32. So since it's the exact same thing on both sides, it's an identity, which means there are an infinite number of solutions. So we write that as negative infinity to positive infinity. It's all real numbers. Now, you may have written in the past something like all real numbers or something like that, but we want to use that negative infinity to positive infinity symbol. Okay? Again, we're going to come back to the fraction problem. This one's the same type of problem. We have to distribute the 2 on the inside. And so we end up with 6 and 3y, negative 2y plus 2. Now I need to distribute the 6. The minus 2 and the plus 7y just carry down. And then when I combine all my like terms, I end up with 13y equals negative 10. And then y equals negative 10 over 13. I want you to leave all of your fractions as fractions in a reduced form. Do not write them as decimals. Okay, so our next problem here that I've avoided, we have fractions throughout the problem. We could deal with the fractions or we could get rid of the fractions. And to get rid of them, what we're going to do is we're going to find a common denominator. And our common denominator is 20. And so now what I'm going to do is I'm going to multiply both sides of the equation by 20, and I'm going to end up with 5x, 40, 16x, and then I'm going to end up with 380. And then I just continue to combine like terms, and I end up with x is equal to 20. Now the reason that we do the fractions is because it makes it a little bit easier to work the problem without those fractions. So that's why I like working fraction problems that way. Alright, so let's look at our next page, and we're going to look at a few of these, and then we're going to go to another video. So the first one is dealing with absolute values, or all of these are, but this first one, you'll notice that the first 4 problems that we have only have one absolute value bracket. And then as we get down here, we end up with 2 absolute value problems. And so we're going to treat those a little bit differently. So on this one, what you're going to have to remember is that anytime you have absolute value, you're going to set the problem equal to the positive and the negative and then solve it. So the solution here is x equals 6 and x equals negative 6. It gets a little bit more complex. So I'm going to take the 2x minus 3 and I'm going to set it equal to 5. And I'm going to take the 2x minus 3 and set it equal to negative 5. And I'm going to solve both of these problems, and I'm going to get x is equal to 4 and x is equal to negative 1. Now as we get into more complicated problems, you need to remember to double check your answers. So we would take the 4 and substitute it back in here. 4 times 2 is 8. 8 minus 3 is 5. And so that one works. Negative 1. 2 times negative 1. Minus 3, so that would be negative 2 minus 3 is negative 5, but the absolute value of that is positive 5, so that one works also. Now this next one, when we have problems like this, where you have a number of things with the absolute value, you've got to isolate the absolute value before you do the positive and negative. So we're going to move the 16, and then we're going to divide both sides by that 3 that's on the outside. So now we've isolated the absolute value by itself. Now we're going to set the absolute value equal to positive 6 and the absolute value equal to negative 6. And when you solve those two problems, when we add 5 here we get 11, and when we add 5 here we get negative 1. So our two solutions are x equals 11 and x equals negative 1. Alright, we're going to look at these two problems because they're in front of us, and then we're going to go to another paper. So on this one, I want you to find the value of x. Now this is what we refer to as a literal equation because there's variables throughout the problem. So you're going to end up with a variable answer. So there's a statement here that says c is greater than 0. Now the reason that statement is there is because you can never have an absolute value equal to a negative number. So c can't be negative. And the same thing for this problem. B can't be negative. So we're going to start this off the same way. We're going to divide both sides by 3. So now we're going to set both problems equal to positive and negative. Now, it almost seems like I'm contradicting myself because I'm making this a negative c. But I have to remember that I still have to, in order to solve the absolute value, I have to treat c as a positive and negative, just like I did on the first problem, and this problem here, and this problem here. So even though it started off positive, I still had to treat it like it could be negative. And then I want to add d to both sides. Add d to both sides. So I end up with these two solutions. C divided by 3 plus d, and negative c divided by 3 plus d. This is a similar type problem. We're going to take the absolute value and set it equal to b and negative b. Now in this case, there's nothing else with the absolute value term, so I don't have to do anything first. And then I'm going to add a to both sides to get that away, and I'm going to divide both sides by 2. So those are my final solutions there. Okay, let's look at this last problem over here, and then we're going to go to another video. We'll have the rest of them. So we have x plus 3 over 4 equals 6. So I'm going to set the x plus 3 equal to 6 and the x plus 3 equal to negative 6. So to solve that, I need to do cross multiplication. So I'm going to have x plus 3 equals 24. So imagine that this is 6 over 1, and this is negative 6 over 1. And then I'm going to subtract 3 from both sides, and I get x equals 21 and x equals negative 27. So remember, you always need to check your answers. So I need to take the 21 and plug it back into the original problem. So I take the 21 and put it in here. So I get 21 plus 3 is 24, divided by 4 is 6. And then I plug negative 27. Negative 27 plus 3 is negative 24, divided by 4 is negative 6. But the absolute value is positive 6. So keep watching for the next video on the rest of the material.